Hello everyone, hope you all are doing well. So today we will be discussing about the microservice architecture in detail. We will discuss the advantages of microservice architecture and the challenges that users generally face while working with microservice architecture. Then we will discuss about the Spring Boot and how we can create microservices with the Spring Boot. And then we will discuss the Spring Cloud modules, all the modules that are required in creating microservice architecture, and then we will do the demo. So let's proceed. So, what basically is microservice? Let's get to know about that. So, microservice is a small, loosely coupled distributed service which acts as a component or part of a whole large application. So, in microservice architecture, the whole large application is divided into chunks or small parts of application which worked independently, deployed independently, and developed independently. So it allows us to break the large application into manageable parts and with defined responsibilities. So this way of building application is considered a modern way of building applications, and it is also providing us the way to write applications without the vendor deadlock. It allows us to write one microservice with Java and other with Python as well. So this is are the main features of microservice, and this is basically what microservice is. So here we can see that, I mean, we can visualize the difference between the monolithic architecture, which is the traditional approach, and then the microservice architecture. So in the monolithic architecture, it has the one unified database and then the unified data interface and then business layer. But at the microservice, each core business functionality is divided into different microservices, and it has its own databases as well. And then all the microservices combined together is making a whole large application which will work together and provide the distributed architecture. So here are the main advantages that we are getting from the microservice architecture. So one of it that is that it is loosely coupled. So it has the small independent part of the application which are loosely coupled, and they work independently. They don't depend on each other. And so one of the if one of the component goes down, the whole application does not go down. Only that component go down, and the application will work according to the requirement. And it has improved fault tolerance as well. Like I already told you that it doesn't go down with the just the single module. So it improves the fault tolerance, and it also eliminates the vendor or technology lock-in that only one vendor or technology can be worked, like Java or Python. We can work on different vendors and technologies, and we can come out of that vendor deadlock. And it is very easy to understand because of the chunks of the application. Like it has a small chunks of application, so it is very easy to understand, and it is very simpler and faster in deployment as well. Like each chunk can be developed and deployed at very fast pace, and it is scalable as well. Like whenever the scalability issue comes in the large application, it is very difficult to manage, but it is easy in those microservice architecture to manage the scalability as well. So along with the advantages that microservices had, it has some challenges as well. So let's discuss about that as well. So as you all know that microservices are developed and deployed independently. So there are a lot of smaller components which are being developed and deployed, and we have to automate the deployment stuff and monitoring, because without the automation, we will not get to know about which chunk is deployed and which is not deployed, and we have to communicate it very efficiently. So automation is the solution for that. So it is a challenge, so we have to do the automation in microservice. And then we have the visibility issue as well. So we have the smaller chunks of the applications which are divided at multiple places. So we have we have to see where the issue is coming from. So we have to provide the visibility and monitoring tools for all the microservices to understand what's going on between the applications. So visibility is the main challenge with microservices as well. And then we have the configuration as well. So multiple applications have configurations which are necessary for the application at runtime. So all those runtime configurations will be a challenge to manage, and we have to manage that in microservice architecture as well. So now we will discuss about Spring Cloud. So Spring Cloud is basically a part of Spring Boot. So Spring Boot is a framework of Java which helps us create REST APIs easily and efficiently. So what Spring Cloud does is that it helps us create microservice architecture by identifying patterns in distributed system easily, and it also helps us create a microservice efficiently and quickly. And Spring Cloud also helps us in the communication and configurations of microservices as well. So here are the Spring Cloud modules that we will be discussing today, and then we will be doing the demo of the components as well. So Eureka server is the server where we deploy our all the microservice, and then at the unified space we will be able to see all the services that are registered in service registry, and then monitor which service is up and which is down in the service registry. And then we have API gateway. So it works as a gateway between the application between multiple applications which are distributed across the systems. So whenever the API call comes, it will go to the gateway, and then gateway will decide which one. Gateway will decide where this application where this call have to be routed. So API gateway works as a gateway between all the applications, and then we have Zipkin. So it is for log tracing. So what's going on between application, how many times the application got hit and what it returns. So all the logging details we will be able to visualize in Zipkin. And then we have Spring Cloud config server as well. So it will have all the configurations for the applications which is necessary at the runtime. So we will deploy that on GitHub server and then fetch it at runtime. So it will work as a config server for us. And then we have a strict dashboard as well. So a strict dashboard is fault tolerant. It provides a fault tolerance visibility for us, like we can visualize what's happening in the application. So all those modules we will discuss in detail. So all those module we will be doing the demo right now. So now we will be doing the demo of all the modules that we discussed. So here is the department service. So what this service does is stores the information about department, like department ID, department name, and all the details about department, and it is running on port 9001. And here I have another application which is user service. It stores all the information about users, like username, user ID, and all this stuff about user email and stuff. So these are both independent applications and both are deployed independently. But we have to create the microservice architecture and we have to make the communication in between them, and all the modules also we have to discuss. So here I have one more application which is service registry. So it works as a registry and it registers all the applications that are deployed. And here I have the cloud gateway application as well. So this application works as a gateway between all the microservices, and whenever any calls come to the gateway, it will route to the right path or right application. And here I have a strict dashboard as well. So we will do the demo of strict dashboard. I'll show you that as well. And at last, we have one more application. It is a cloud config server. So it is a configuration server which picks up the runtime configurations from this GitHub link. So it picks up all the necessary configurations which are required in all the microservices. So it picks it up from this link. So it works as a cloud config server. So if we go to Postman and if we go here 9001 department, so if we hit the post, so you can see at this is the URL for department service. So we can see the department is getting saved. Now 9002 this port, this is the URL for user service. So if we save that, so you can see the user is getting saved as well. So both the services are working fine. So now if I do the get and if I do the user ID 1, so I can see I am able to fetch the user as well from the user service, and this user fetched the department as well with the department ID 1, because the department ID was 1, so it was able to fetch department from the department service. So now let's do that with the API gateway. So here these both are different, but here we have the same URL for 9191. So if I write the URL for departments and if I go to the post, and here is the body and here it is defined. So if I post it, you can see I am able to post the details about the department in from the gateway as well. So this gateway routes the application to the right application, which is the department service, and it posted the information there. And now with the same URL, if I do save the information in user, and here from here I picks up the information of user, and then if I do the send, so you can see it is able to save the user details as well. So this gateway is working fine. So now if we do the get request, it is working fine as well. So it is able to fetch the results from user service, and user service calls the department service as well. So now you can see that gateway works perfectly, and how this is how it works, and it routes the call to the right URL or right application. Now if we see here, this is the Eureka server that we have deployed, and this is the service registry that we talked about. So it registers all the applications that are deployed. So you can see API gateway is up and it is deployed, config server is up, department service is up, history dashboard is up. So all the services are up. So you can see and visualize here in the dashboard. So here is the historic dashboard. You can see we do a couple of calls to user service. So here is the graph for that, and we did one call to department service. Here is the graph for that, and you can see the errors percentage and stuff. So here 0% error, 0% error because no errors found. So here in the historic dashboard, we can see the faults and stuff, and we can helps us. It helps us identify the faults and then correct them. And then here is the zipkin as well. So if I do service and then if I run query, so these are all the services that I called. And here I can see the duration and all the durations that this call took to return the result. And here I can see all the necessary details, that it was get request and it was user's path, and then it has the one as a parameter. So all the details are here in the zipkin. So we can utilize those details, and it helps us in our microservice architecture pretty much.